Hi, welcome back. This is going to be the solution for an RL circuit for preparation for the exam. So in this case, the switch has been in position 1 for a really long time and then moves to position 2. So we want to find both the voltage across the inductor and the current going through the inductor. So with that, we need to first find the value of the current in the inductor because we know that is the characteristic that stays the same at a change. So sitting here for a long time, it's going to be a wire. It will have been in position 1 for a long time before it moves into position 2. So this is going to be the circuit that we analyze. We want to find the current IL, which will be V3 over 4K. And to do that, we need to find V3. So we know this didn't get marked, I guess. This is going to be 3 milliamps. And this is going to be V3 over 8K. And so we have V3 over 8K plus 3 milli plus V3 over 4K. Combining like terms, you have 1 over 8K, and then the 1 over 4K becomes 2 over 8K minus 3 milli. And then dividing this becomes 8K over 3. And so we end up with a value of minus 8 volts. So this gives us an IL of a minus 8 over 4K for a minus 2 milliamps. So this is going to mean that when we have now the switch moves to the new position, then the current is going to stay the same through this. So this is going to be a minus 2 milli. Make this easier to read. So minus 2 milli as far as the current going through it. And here we see that this VL is going to be 0. After the switch, this is no longer 0, and we need to determine what that value is. So to find that, we again want to know what the node voltage is, and then we need to determine, call it V4. And so I'll call this V1 this time. And to find V1, we're going to define the current in this branch as V1 minus 12 over 2K. This is going to be already defined as 3 milliamps, and then we also know the minus 2 milliamps. So another thing we could do is, because we know the currents in the two branches, we could find the current going through the 2K also by just summing the two currents. So I could have defined this as kind of IX, and we could say, well, IX has got to be, if it's going out and 3 millis going out and the negative 2 milli is also going out, then we could also find IX this way. So IX would be a minus 1 milliamp. So we could find that, then we could find, we know V4 also is going to be, current is flowing in this direction as a minus 2 milliamps. So plus minuses are the same, so this would be a plus I, which is actually negative minus 2 milli times 4K. And so this is going to be a minus 8 volt drop here. V1, you can either find from Ix, which would be plus minus this way, so a plus is equal to V1, so we have plus 12 plus Ix times 2k is equal to V1. So V1 here ends up being a 12 plus a minus 1 times 2k for a plus 10 volts. And then VL, we can do a plus, so plus VL plus V4 is also equal to V1 of 10. So VL in this case would be 10 minus a minus 8 for a 18 volts. So if we wanted to find the node voltage instead, it would have been V1 minus 12 over 2k plus 3 milli plus a minus 2 milli equals 0. And solving this, 12 over 2k minus 3 milli plus 2 milli, and then multiplied by 2k, you end up with V1 is 12 minus 2 for 10 volts also. So whichever method you want to find, you're going to find V1, and then from V1 you have to find VL by the voltage drops around it. So VL is going to be 18 volts. So this is going to be my initial value of 18 volts for VL. My initial value for the current, IL, is going to be that minus 2 milliamps. So now we want to find the final time. So t equals infinity. Switch now is in this position. And this is again going to be a wire. So we note right away that this has got to be 0 because there is no voltage drop across the wire. So that makes that value easy, that the final value for VL will be 0. For IL, again, we'll define this. Let's call it V2 this time. So this will be V2 minus 12 over 2k. 3 milli is already defined, and in this one it's going to be V2 over 4k. And that will be also equal to IL. And so we have V2 minus 12 over 2k plus 3 milli plus V2 over 4k equals 0. And then we combine the like terms, changing that 1 over 2k to 1 or 2 over 4k minus 3 milli, and then we're going to combine this for 4k over 3 to give a minus 4 volts. So now IL is a minus 4 over 4k for a minus 1 milliamp. So this will be the final value for the current IL. So we have, this is the final value for this one, VL is 0, and this is our final stage. So now the last step is to find tau. Again, this is going to be at the final switch position. We take out the element, put A to B, and then we're going to find the pathway between each one, removing the sources. So RTH, this will be an open for the current source and a wire here. And 3K will be floating, the 8K is floating, so then RTH is going to just be 4K plus 2K for a value of 6K. Okay, sorry, I made a math mistake up here. I just realized, so redo this one. Okay, so I forgot to bring over the 12, a plus 12 over 2K minus 3 milli. And then 2, okay, that one looks better. So this is multiplied by 4K over 3. So this became 6 milli minus 3 milli times 4K over 3 to give me a value of a plus 3 milli. And so this becomes, V2 becomes a plus 4 volts. And then IL is going to be plus 4 volts over 4K for a plus 1 milli. Sorry about that error. That did get corrected, so that's a plus 1 milliamp. And going back to tau, we need tau for an inductor is L over RTH. And so L was given as 2 millihenry. So 2 milli over 6K ends up giving 1/3 times 10 to the minus 6 seconds, or 1/3 microseconds. And then the expressions for t greater than or equal to 0, we have VL of t. The final value is 0, and that initial value was 18 volts. So 18 minus 0, e to the minus, and 1/3 micro becomes 3 meg. So we can write it on the top just to make it look better. And then IL of t, the final value is that plus 1 milli, and the initial value was a minus 2 milli. And this is then the final solutions for both VL and IL. Another way to get the voltage VL would be to find IL first. So if we found IL, and then we know that VL is L dIL dt, and so we can take the integration or the differentiation of that, and we would end up with the VL equation also. So either way, you can still figure that out. All right, thank you for watching.